This section is about going back and forth between equations and graphs of functions when you're doing translations. So you should be comfortable looking at a equation with a translation in it and understanding what the graph will look like, and you should be comfortable looking at a graph and understanding what the equation would look like. Okay, first this is a graph of the cube root of x. Notice how it's that curvy lightning shape. It's sort of sideways. It passes through 0, 0, and it curves up to the right, and then it curves down over here. So now here's the translation of that graph. I have a +2, which is attached to the x. It's under the cube root sign. And I also have a -3, which is at the end of the equation. The one that is attached to the x is going to move your graph right or left that many squares. And the one that's added on to the end is going to move your graph up or down that many squares. The horizontal translations are always going to be the opposite of what you think. So when I see this translation, I think +2, that's to the right 2, but it's not. It's the opposite. So this one is going to translate my graph left 2 spaces. It's attached to the x, so it's going to be the opposite. Then the -3 at the end is going to translate my graph down 3 spaces. The way I graph that, for this particular function, the really important point is 0, 0, so I'm going to follow that point. I'm going to take that point 0, 0, and I'm going to go left 2, and then I'm going to go down 3, and there's my new point for 0, 0. So 0, 0 went here. It went right and down, left and down, and became that new point. Now from 0, 0, my function curves up and passes through 1, 1, and then continues up. So this new function is going to pass through this point and continue up. And then it's also going to continue down and pass through this point, just like this function continues down. So this point right here is like 1, 1. -1, -2 is like 1, 1, because if I take that 1, 1 point and I go left 2, down 3, I wind up here. -1, -1, if I go left 2, down 3, is going to wind up right here. So those 3 points I can clearly see on my new graph. The key is that every single point on this graph, like this point here, is going to go left 3, down 2. That one's a little harder to graph accurately, but every point on that blue graph gets moved to a new point by these 2 translations. My final graph should have the same shape as the original graph. It should only be moved on the plane. Okay, we're going to try another one. We'll go a little more quickly. This is the square root of x graph. You should be comfortable with the square root of x, that it starts at 0, 0, and then continues upwards. So my new graph has a -3 that's attached to the x. So that's going to be a left-right change. And then it has a +1 that's added onto the end, so that's going to be an up-down change. So the -3, normally I think of -3 as this direction, but it's not that direction because it's opposite. So this -3 is going to be right 3. And then the one that's added onto the end, we don't do opposite for up and down. That's just going to be up 1. So the point that's important again is 0, 0. I'm going to take that 0, 0, and I'm going to go right 3. And then I'm going to go up 1. And now there's my new point for 0, 0. Then my graph curves up, passes through 1, 1, and continues up. So that's the new square root function. Same shape, just moved right 3 and up 1. Okay, here's another graph. This is an exponential function, so you should be comfortable with 2 to the x. This is exponential growth. Exponential growth has an important point at 1, 1. So 1, 1 is going to be a point that we're going to be very careful to move. Attached to the x, we have a -3. Minus 3 attached to the x is going to be right 3. So we're going to take that point and we're going to go right 3 with it. It's the opposite of what we think. Negative 3 is normally to the left, but we're going to go right because we do the opposite for horizontal. And then the minus 4 at the end is going to go down 4. So we're going right 3, down 4. I'm going to take that 1, 0, 1 point, which is important. I'm going to take that point, I'm going to go right 3, and then I'm going to take that same point and I'm going to go down 4. All other points are going to follow that same pattern. So right 3, down 4 would be here. This one here would go right 3, down 4. You see how we're going to have this asymptote is going to be shifted down 4. So instead of being an asymptote at 0, that asymptote gets moved down to negative 4. And so we still have an asymptote. We still have the exact same shape. It's just that we've been moved right and down. Your asymptote should remain at negative 4. It should not be anywhere else but negative 4. So your graph should not cross negative 4. Okay, this is a parabola. And now we're asked for the equation. So the original parabola is the parent function. That one passes through 0, 0. That's the vertex. And if I follow that vertex, I should get my translations. So it looks like the vertex moved 3 to the right and 2 down. So 3 right and 2 down. So that means my new equation, I'm going to call it h of x, so it can have a different name. Attached to the x, we're going to have a 3. Normally we'd say plus 3, but we do the opposite, so it's going to be minus 3. And then we're going 2 down. Down doesn't change signs, so we're going to just say minus 2 to show that 2 down. This is going to tell me that we're going right 3, and the minus 2 is going to tell me we're going down 2. Again, we always have to figure out what's the important point that we're going to follow. For this graph, it's going to be the vertex. I'm going to follow the vertex to get the new point. All right, that's another brief lesson on translations. I hope that it helps, and please let me know if you have questions.